Hello again. This is the second part of the Squareboi assembly guide. In this video, I'll be going over the RAM and ROM daughterboards. Let's start with the RAM board. I will be using a 32 kilobyte SRAM chip, as it is what I have on hand, but the exact same procedure could be used to mount non-volatile FRAM instead. The chip has quite a small footprint, so I'll be using 0.5mm solder as opposed to 1mm one, in order to give me more control over the amount used. I'll tin one of the edge pads to help hold the chip in place as I align it. Place the chip on the surface of the board, making sure the pin 1 marking is aligned with the dimple on the circuit package. Take your time with this. Getting a good alignment here will make all subsequent soldering a lot easier. Once I'm happy with the positioning, I tack the chip into place by heating up the pads I had previously tinned. By only soldering 1 or 2 pins at first, I can gently push the chip back into alignment if necessary. Finally, I'll solder the 4 corners to hold it securely, then go over the remaining pins one by one. It is fairly common to get bridged pins during this process. All I have to do to fix them is add a bit of liquid flux, clean the tip of my iron, and heat them up again. Surface tension should easily remove the excess solder. I'll also take this opportunity to go over all the pins again, reflowing any that look uneven or disconnected. When soldering surface mount parts, it is very important to verify your work carefully, ideally using magnification, to make sure no pins were missed or bridged. Next, I'll install the capacitor. I'll be returning to 1mm solder for the through hole parts, as I find it more convenient to work with. It's time to add the pin headers. I'll snap them to size, using the holes in the board as a guide. I'll use a spare board as a way to keep the pins aligned as I solder them. I stack the boards with the header between them, and gravity keeps everything in place until I have the 4 corners stacked down. Soldering the headers happens in much the same way as in the main board, though a bit of extra care must be taken not to touch the nearby surface mount pads. The RAM board is now fully assembled. I'll wash it with isopropyl alcohol to remove the excess flux, then move on to the ROM board. Let's start working on the ROM board. For this video, I'll be building the longer version that can be stacked for higher memory capacity. The same procedure could be used for the non-stackable version, as the only difference between them is the removal of a few components. The flash IC used has a TSOP48 package, with pins that are both small and close together. It's still perfectly possible to hand solder, but it will take some patience and care. I'll align it as best as I can. Magnification can be quite useful at this stage, so I'll be zooming in and actually viewing the chip through my camera's screen. I apologize if this causes it to go out of frame at times. Unlike the RAM chip, this one sits flush against the board, so I can't use the pre-tinned pad technique. Instead, I'll use the long pads to flow the solder in, without resting my iron against the chip itself. This does not make a good long-term connection, so I'll reflow it after I've got the other pins secured. The alignment is pretty critical, so I'll be adjusting the chip's position quite a bit. Don't be discouraged if you need several tries to get to a point you're happy with. Finally, I'll tack down the other corner to secure the chip into place and start soldering the rest of the pins. You'll notice a lot of bridged pins. I found the most reliable way to solder this kind of chip is to use a bit more solder than strictly necessary, then remove the excess afterwards with a clean-tipped iron and a lot of flux. Now, I'll move on to the demultiplexer chip. It is very small, so be careful not to drop or lose it. The markings on it can be a bit hard to read. Make sure it's aligned properly, with a small dot turned towards pin 1 on the board silkscreen. I've actually placed it the wrong way here. Thankfully, I caught my error before soldering it down. Let's install the through-hole components. The resistor and capacitors are installed in the same way as in the main board, so I'll not go into too much detail about them. The stackable ROM boards rely on a jumper to tell the system which one should be used at each time. I'll use the JP0 jumper to indicate this board contains a lower 2 MB of memory. If I was to build another board to stack on top of this, I'd set the JP1 jumper on it. Time to install the headers. I'll be using stackable headers for this board, as it's the lower one in the stack. If you're building the top board of the stack, or the non-stack inversion, use common pin headers instead. Ideally, you would use 16 pin headers for this board. If not available, it's possible to replace them with two 8-pin headers each instead. You might need to sand down their edges a bit, so that everything fits properly. I'll insert pin headers on top of the stacking ones to help maintain alignment as I solder them. If the headers are hard to insert fully, that's a sign that I need to sand the middle a bit further. Getting a good fit now will make the boards a lot easier to connect later. Like before, I'll use a spare board as a guide to help keep things in place while I solder them. Time to solder it in. Since the headers are split in the middle, I'll solder the center pins as well as the edge ones before going over the rest. I made a mistake during this build and forgot to solder in one of the capacitors. Thankfully, it's a simple fix, and I can just add it in now. And that should be it. The RAM and ROM boards are now done. In the next few videos, I'll go over the programmer board and final assembly for the system. Thank you for watching, and have a nice day.